This lesson is on systems of equations with quadratics. So we're going to be learning about how to solve a quadratic system of equations, um, a quadratic with a quadratic, quadratic with linear equations, and also we're going to look at quadratic systems of equations that have no solutions. So a quadratic system of equations is a system of two or more equations where at least one of them is a quadratic, and you can solve them either graphically or algebraically. Now, given that you get to use the Desmos graphing calculator on the SAT test, uh, definitely I would say to do that method for these. But we are going to go over still how to graph these both with and without the calculator. So again, a system of equations can have 0, 1, 2, or it can also have infinitely many solutions. And this is with a quadratic and a linear equation. So remember, quadratics are a U shape and linear equations are just a straight line. So the example that I drew out, there's 1, 2 solutions total. Now it says there can be infinitely many solutions. We'll look at what that means in a moment. But if 0 solutions would be something like this, 1 solution would be something like that. All right, so to solve a quadratic and linear systems of equations, the best approach to use is substitution, and then we eliminate the variables and solve. This first one says find all the solutions for the system of equations. So probably the easiest thing to do would be to just graph this on Desmos. And so if you go to desmos.com/calculator, you can graph this on the calculator. So our first one is x squared minus 4x plus 7. And our next one is x minus 3. We can automatically see there is no solution here. These graphs don't cross anywhere. So we can see that right away from graphing this. I typed all this in with the x squared. You can go down here and you can type in a squared term if you need to. That's up to you. So another way to solve this algebraically would be to set them equal to each other. And I may have typed this in incorrectly. Let me go back and double check. X squared minus 4x plus 7 and x plus 3. Okay, so sometimes these slides are not correct. So let's continue anyway, and we'll see what happens here with these slides. So here we're setting these equal to 0, and we're factoring these. We get x minus 4 and x minus 1. Just double checking here to make sure I typed everything in correctly. And it looks like I did make a small error. So I typed x minus 3. It was supposed to be x plus 3. So that's just another example of why it might be a good idea to just solve these algebraically. If you make a small typo, if you're getting through the test as quickly as you can so that you have more time for the more challenging ones, and you make a small error like I just did, it might be in your best interest to solve these algebraically instead. So we get two solutions here, actually. We get a solution of 1, 4, and 4, 7. So here's how we would do that algebraically. We set these equal to one another. We can set it equal to 0. We can subtract x on both sides. That gives us negative 5x. Subtract 3 on both sides. That gives us a 4 on the left side. Now we can factor this with the AC method. The A times C method, A is 1, that's the number in front of the x squared term, and C is 4. So this would be 1 times 4 is just 4, and all the factors of 4 there's 4 times 1, 2 times 2, -4 times -1, -2 times -2. A lot of times people forget the negatives when we have just a positive answer. So just keep that in mind that you'll want to write the negatives there as well. So these end up equaling what b is. -4 plus -1 gives us -5. So we just write x minus 4, quantity x minus 4 minus quantity x times quantity x minus 1. And if we set both of those equal to 0, we get x equals 4 and x equals. Now that we know what x equals for x equals 4 and x equals 1, we're going to go back up here and we're going to plug that in for our quadratic. And when we do that, we get, for when it's 4, we say y equals 4 squared minus 4 times 4 plus 7, y equals 16 minus 16 plus 7, and we get y equals 7. If we plug 4 in for this second one, we also get y equals 7. So the corresponding y value is y equals 7 for when x equals 4. We do the same thing for when x equals 1. We should get 4 for both of these, but let's double check. So we get y equals 1 squared minus 4 times 1 plus 7. That's y equals 1 minus 4 plus 7. And that's going to be y equals 1 plus 7 is 8 minus 4. It gives us 4. If we plug in 1 for x for the second one, we get y equals 1 plus 3, and y also equals 4. So those are our corresponding y values, and those are the points where they cross. All right, this next one says, what is the set of solutions to the system of equations below? We're going to do the same basic idea. So we set these equal to each other. Then we set it equal to 0. Then we factor with the AC method, and we get x plus 4 times quantity x plus 1. We set each of those binomials equal to 0. We get x equals -4 and x equals -1. Then we go back and plug that in. So we're going to plug in 4 to the first equation and to the second equation, and we should get the same answer of 1. For the second part, x equals -1, we would plug that in, and we will get -5 if we plug that in for these two equations here. A system with two quadratic equations can have 0, 1, 2, or infinitely many solutions. You set them equal to each other if they're both set equal to y, and then you solve it for x. And you can graph them as well. So here we have another example. It says, what's the set of solutions to the system of equations below? Here we can subtract, or we are adding x squared to this side. So we're adding everything. Now let's take a look, actually. Let me make sure that this example was done correctly. So if we add this x squared over here and this x squared, now we have 8x minus 8 equals 2x squared minus 6x plus 4. If we continue, we're going to minus 8x and minus 8x. We get -8 equals 2x squared minus 14x plus 4. And we're going to add 8 to both sides. We get 2x squared plus, minus 14x plus 12. And so that's how we get this equation here. So let's take a look at what we've done so far. We've set these equal to each other, and now we've set it equal to 0. We're going to do the AC method again. But before we do that, we can actually divide everything by 2. So we can divide all three of these terms by 2. That's how we get the x squared minus 7x plus 6. Then we can do the AC method, which helps us a little bit because we don't have to think about so many numbers to multiply. If we did 2 times 12, that would give us 24. We'd have to do the AC method there and find all the factors for 24. But now we have 1 and 6, and so we just have to do 1 times 6, which is just 6, and that's 6 times 1, 2 times 3, -6 times -1, -2 times -3. So that's not very many choices to go through to figure out what equals -7. -7, if we add these factor pairs, is -6 and -1. And so we can write it in factored form like that. Once we get the factored form, we solve for what x equals. We just get x minus 1 is 0, and that means x equals 1. And x minus 6 equals 0. Just add 6 to both sides. X would be 6 there. Then we're going to do the same thing we did in the last problem. We're going to plug in 1 and 6. So we're going to plug in 1 for x, and we should get -1 for y. We plug in 6 for x, and we should get 4 for y. All right. So this next one is saying, what's the set of solutions for this system below? And again, we have two answers here. We set these equal to 0. We set them equal to each other. We set it equal to 0. Then we factor. Then we figure out what x is. We plug that value for x into the first equation, figure out what our answer is, plug that same value of x into the second equation, figure out what our answer is. And here the solution is -3, -11. Let's just type this into Desmos because I think that we could save a lot of time by just typing these into Desmos. So the first one's 2x squared plus 12x plus 7. And I'm just typing this in. You can, when you're typing the x squared, you can type x shift 6 and it'll bring you to the exponent. And then when you type your exponent, make sure to press the right arrow key to go down in order to start doing the rest of your equation. If you don't press that right arrow key, it's going to keep typing up here on the exponent, whatever you type. So that's our first equation. Our second equation is x squared plus 8x plus 4. And I've actually just gotten in the habit of pressing the right arrow after I do every single term, just to avoid that error from happening where it writes incorrectly of where I want it to write. So now we can see where it intersects, and that's here and here. So -3, -11, and -1, -3. If you have time to check your work, definitely do the graphing method and the algebraic method if you have time. If you don't have time, that's perfectly okay. Now, if there's no solutions at all, the graphs will never cross. And if we solve this algebraically, we get x squared minus x plus 2 when we end up setting these two equal to each other and then solving it for 0. So if we do the AC method here, let's see if we can get this to factor. So if we did A times C, that's 1 times 2, which is equal to 2. And 2 times 1 and -2 times -1 is the only way that we can multiply to get to 2. So if we add those together, that's 3. If we add those together, that's -3. And that does not equal -x. So these are never going to cross. Here's another example where we have no solutions. Again, we set these equations equal to one another, set it equal to 0, and then we try to factor it. And it says quadratic formula will not yield any real solutions. Now, if you do the quadratic formula here, you might get a strange answer. So let's actually try that really quick for the quadratic formula for this part. So A is 1, B is -4, C is equal to 6. So the quadratic formula says minus B plus or minus the square root of B squared minus 4AC, all divided by 2A. So minus b is negative negative 4. So that would be positive 4, plus or minus the square root of b squared is negative 4 squared minus 4 times 1 times 6, all over 2 times 1. I'm just going to write this over here. 4 plus or minus the square root of 16 minus 24, all over 2. Now let's look at the discriminant here. This is 4 plus or minus. The discriminant is 16 minus 24. That's a negative 8 all over 2. You cannot take the square root of a negative number. If you do, you have to use imaginary numbers. So this would be 4 plus or minus I square root of 8 all over 2. So that's how we write a negative square root. We bring an I to the outside, and then the negative goes away. If you ever get an answer with an I, that means that there is no real solution. All right. So again, use your calculator and the algebraic method if you have time. I realize I made an error in the beginning with just putting a minus instead of a plus. So that could happen. So just be aware of that. And infinitely many solutions is when the graphs are stacked on top of each other. So you might be wondering, well, I just see one graph here. What does that mean? That just means that it's the same graph on top of itself. And so that's infinite solutions.